Hi to everyone. In all my previous videos, I have explained about random processes temporal characteristics. That means how a random process is going to changing with respect to time, like the parameters are mean, mean square, autocorrelation function and cross correlation function. Now, in this video, I would like to explain what are the related problems. So thus, the contents in this video are problem solving on random process temporal characteristics. In that, the first problem is show that random process x of t is equal to a cos of omega naught t plus theta is a wide sense stationary if a and omega naught are constants and theta is uniformly distributed random variable on the interval 0, 2 pi. They have given this problem. This problem is based on WSS, that means wide sense stationary. For the case of WSS process, it has to satisfy two conditions. The first one is mean should be constant and the second one is autocorrelation function should be function of tau only. So now to do this problem, consider what is the given data. The given data is nothing but the random process x of t, that is equal to a into cos of omega naught t plus theta, and they have also given it is a, we have to show that it is a WSS process, okay, and a and omega naught are constants. Theta is the uniform distributed random variable. Then for the case of uniform distributed random variable, its corresponding density function is given as f of theta is equal to 1 by b minus a. What is b and what is a is nothing but they have given the intervals as 0, 2 pi. This is nothing but a and this is b. Therefore, this is equal to 1 by 2 pi minus 0, that is equal to 1 by 2 pi. This is the density function of the theta. Now, in the first step, we have to calculate what is the expected value of the random process, that is E of x of t. This is nothing but E of, from the given data, x of t is equal to a into cos of omega naught t plus theta. This is equal to, a is a constant, get out the expected, then a into E of cos omega naught t plus theta. This is equal to a into, apply the expected formula. E of x is nothing but in general integral minus infinity to infinity that function x into fx of x dx. Fx of x is the density function of the that corresponding x. Therefore, here it can be written as integral minus infinity to infinity. Now, the function is nothing but this entire, that means cos omega naught t plus theta into, here the density function is there. In the problem, they have defined as theta is the uniform distributed random variable. Its corresponding density function is f of theta. And do integration with respect to theta, that means d theta. This is equal to a into, in the next step, you have to substitute what is f of theta, that is equal to 1 by 2 pi, whose interval is nothing but from 0 to 2 pi only. That's why now the integration limits are integral 0 to 2 pi cos of omega naught t plus theta into, now f of theta is 1 by 2 pi. This is 1 by 2 pi d theta. That is equal to 1 by 2 pi is a constant, get out of the integration. Therefore, this is a by 2 pi. Integral of cos theta is nothing but sin theta. Then applying that formula here, this is sin of omega naught t plus theta. Now we are doing the integration with respect to theta. Here theta does not contain any scaling factor. That's why the integration of cos of this entire is nothing but equal to simply sin of omega naught t plus theta only. Now apply the limits. This is from 0 to 2 pi. Therefore, E of x of t is equal to, in the previous step we are having as a constant as a by 2 pi, and we are having sin omega naught t plus theta here. Applying these limits from 0 to 2 pi. Instead of theta, now we will substitute as the lower limit. That's why here you can written as sin of omega naught t plus 0 minus sin of omega naught t plus pi. Further simplifying, we will get as a by 2 pi sin of 0 plus something is nothing but sin 0 is nothing but sin omega naught t minus sin of here we are having as 2 pi, isn't it? So sin of 2 pi plus theta is theta only. This is also equal to sin omega naught t. Now here you can observe both are having the same. That's why this minus is nothing but equal to 0. That is a by 2 pi into 0. This whole is nothing but equal to 0. Therefore, the expected value of the given random process x of t is nothing but equal to 0. That means it is nothing but a constant satisfying the first condition of the WSS. That means wide sense stationary. Next, we have to calculate the autocorrelation function. The autocorrelation function of the random process, that is ACF, is nothing but indicated as Rxx of t comma t plus tau, that is equal to E of x of t into x of t plus tau. Now substituting this x of t from the given equation, that is nothing but E of, in the problem they have given x of t as a into cos of omega naught t plus theta into x of t plus tau. Now for that case I have to write as a into cos of omega naught, instead of t now we have to write as t plus tau, omega naught into t plus tau plus theta. For this entire expected value here we are going to calculate it. Now this is equal to a into a is nothing but a square is a constant, get out of the expected value. So a square into E of cos omega naught t plus theta into cos of omega naught into t plus tau plus theta. Now here you can observe, to further simplify, apply cos A into cos B formula. Cos A into cos B is nothing but 1 by 2 into cos of A plus B plus cos of A minus B. Now using that, this is equal to A square E of, first we will write cos of A plus B, that is cos of omega naught t plus theta plus addition of this again omega naught t plus omega naught tau plus theta. The center is equal to cos of A plus B plus cos of A minus B, cos of omega naught t plus theta minus omega naught t minus tau into omega naught minus theta. For this whole divided by 2 is there, it is a constant, get out of this expected value. Now further simplifying, we are going to getting as a square by 2, expected value of, simplify this, omega naught t plus omega naught t, that is equal to 2 omega naught t. Here omega naught tau is there, plus theta is equal to 2 theta, plus next one is omega naught t minus cos omega naught t get cancelled, and then theta as well as minus theta get cancelled. Remaining term is cos of minus omega naught tau. Now further simplifying, this is a square by 2, expected value of cos of 2 omega naught t plus omega naught tau plus 2 theta plus cos of minus theta is equal to plus cos theta only. That's why this can be written as cos of omega naught tau only. In the next step, we can apply the expected value to both terms. Therefore, it can be written as all xx of t comma t plus tau is equal to a square by 2, expected value of here cos of 2 omega naught t plus omega naught tau plus theta. Now the second term is nothing but cos of omega naught tau. A square but is a common to the both terms. Now here you can see that this is equal to a square by 2. Now calculate this one. This is the expected value of something function. What is the formula in terms of integration? Integral minus infinity to infinity, that entire function cos 2 omega naught t plus omega naught tau plus theta into f of theta d theta. This is the first term. Then expected value of the next one is nothing but, here you can see we are having only tau. Tau is a constant. That's why expected value of a constant is also a constant. This can be written as simply cos omega naught tau. That is equal to a square by 2. Here f of theta is having the limits of 0 to 2 pi. Therefore, this is integral 0 to 2 pi cos of 2 omega naught t plus omega naught tau plus theta into 1 by 2 pi d theta plus cos omega naught tau. Now here you can observe that this is nothing but the a cos function. Doing the integration, the limits of 0 to 2 pi. Earlier also you have done, isn't it? That's where is nothing but equal to 0, because for entire one cycle here we are going to doing the integration. That's why for the sinusoidal waveforms like sine or cos, we are going to getting this value as 0. Therefore, substituting that here, this is a square by 2 into 0 plus cos of omega naught tau. Further simplifying, this is equal to a square by 2 into cos omega naught tau. That is the autocorrelation function Rxx of t comma t plus tau is equal to simply a square by 2 into cos omega naught tau. So here you can see this is the second one where we have proved that the autocorrelation function is function of tau only. Therefore, from 1 and 2, we can observe that it is going to satisfying such that the corresponding mean value E of x of t is equal to constant, and the autocorrelation function Rxx of t comma t plus tau is function of tau only. That means Rxx of tau only. These are the two conditions which has to be satisfied by the WSS process. That's why we have proved that the given x of t is the WSS process. Okay. Coming to the next problem. Let us see here. A random process y of t is equal to x of t minus x of t plus tau. They have given like this expression. Is defined in terms of a process x of t that is at least WSS. That means in the problem they have given as x of t is WSS. Then the first question is show that mean value of y of t is 0. That means E of y of t we have to calculate, that we have to show it is equal to 0. Even if x of t has a non-zero mean value, that means x of t mean value is not 0, but mean value of y of t is 0, that we have to prove this here. In the question B, we have to show that sigma y square, that means variance of y of t, is equal to 2 into Rxx of 0 minus Rxx of tau. And question C is, if y of t is equal to x of t plus x of t plus tau. Here they have given x of t minus, but here x of t plus is there. They have modified. Now in this case, they are going to asking to calculate what is E of y of t and sigma y square. Okay. Now we will do this problem. Let us see. In the first case, they have given this expression as well as x of t is nothing but the white sense stationary. Now we have to solve the question A. Let us see here. First write the given data. Y of t is nothing but equal to x of t minus x of t plus tau, and x of t is the WSS, that means white sense stationary. Then here have to show the mean value of y of t. That's why we are going to calculating E of y of t is equal to. Substitute what is y of t here? E of x of t minus x of t plus tau. Now this is equal to. Apply theorems on expectation. Generally we are having E of x plus y is equal to E of x plus E of y. Similarly, E of x minus y is also equal to E of y, E of x minus E of y. Therefore, here you can apply that formula. This is equal to E of x of t minus E of x of t plus tau. Simply apply the properties of expectation here. Now observe that in the problem they have given x of t is WSS. If x of t is WSS, then its corresponding mean is constant. Given that x of t is WSS, that means its corresponding mean E of x of t is a constant. Let us consider simply as x bar. Therefore, substituting that here, E of x of t is nothing but x bar, and E of x of t plus tau is also x bar only. Whatever may be the corresponding t value, its corresponding mean is always constant. Then x bar minus x bar is nothing but equal to 0. That means the mean value of the random process y of t, which is defined in terms of x of t, its mean value is nothing but equal to 0 now. Here you can see x of t is a random process whose mean value is nothing but x bar. It is not equal to 0, but still e of y of t is nothing but equal to 0. That we have shown here. That only they have asked in the problem. Show that mean value of y of t is 0, even x of t has a non-zero mean value. Okay. Consider the second problem. Show that sigma y square is equal to 2 into rx of 0 minus rxx of tau. First write the given data. Y of t is equal to x of t minus x of t plus tau. And they also given that x of t is wide sense stationary. That means its mean value is constant. Now here we have to calculate the sigma y square. What is sigma y square? That is the variance of the random process y of t. In general, the variance formula is given as m2 minus m1 square. m2 is known as the mean square value, and this is nothing but the square of the mean value, where m1 is the mean value. Okay, so that's why first we will calculate what is m2 here. m2 is nothing but e of y square of t. That is equal to, what is y of t they have given in the problem? This one. Substitute this here, x of t minus x of t plus tau for this whole square. Then calculate the expected value. Then apply a minus b whole square here. This is equal to e of a minus b whole square is equal, nothing but equal to a square plus b square minus 2ab. Hence, it is nothing but here x square of t plus x square of t plus tau minus 2 into x of t into x of t plus tau. Then, apply the theorems on expectation. That means e of x plus y is equal to e of x plus e of y. Therefore, apply expected value to every term. This is e of x square of t plus e of x square of t plus tau minus e of 2 into x of t into x of t plus tau. That is equal to. Now here you can recall in the problem, they have given x of t is wide sense stationary. That means its corresponding mean and mean square all are the constant. Therefore, this is nothing but from the properties of the autocorrelation function, this is equal to simply rxx of 0 plus here also, since it is a WSS process and from the properties of autocorrelation function, this is also equal to rxx of 0 minus 2 is a constant, get out of the expected value. This is 2 into e of x of t into x of t plus tau. This is equal to rx of 0 plus rx of 0 is nothing but 2 into rxx of 0 minus 2 into, here you can see from the definition of the autocorrelation function, this is nothing but rxx of t comma t plus tau, and since it is a WSS process, this is equal to simply rxx of tau only. Therefore, by taking 2 as common here, this is equal to 2 whole into rxx of 0 minus rxx of tau. That means m2, that is the mean square value of the y of t is nothing but equal to this one. Now we have to calculate the variance. Variance is nothing but m2 minus m1 square. Okay. So m2 is this value. m1 earlier we have calculated nothing but its corresponding mean value, which is nothing but equal to 0. Now we have to substitute that here. So thus here we are going to getting as simply sigma y square is equal to, this is m2 value, 2 into r xx of 0 minus r xx of tau. m1 is nothing but equal to 0. Substitute that here, we are going to obtaining sigma y square is equal to 2 into r xx of 0 minus r xx of tau. Thus, we have proved that here the second condition, that is a sigma y square is nothing but equal to 2 into r x of 0 minus r xx of tau. Then coming to the next one, if x of t plus x of t plus tau is there. Now y of t they have given as x of t plus tau. In the previous case they have given as here minus, now it is plus. If that is the case, now we have to calculate E of y of t as well as sigma y square. First we will calculate E of y of t. E of y of t is equal to, substituting y of t as x of t plus x of t plus tau. Now here apply theorems on expectation, that is E of x of t plus E of x of t plus tau. This is equal to, x of t is a WSS process, therefore E of x of t is nothing but simply x bar. Plus E of x of t plus tau. Since it is a WSS process, it is also equal to x bar only. X bar plus x bar is nothing but equal to 2x bar. That means E of y of t, the mean value of y of t is nothing but equal to 2 into x bar. In the previous case, we are having here minus, that's why x bar minus x bar is nothing but 0. Now here for the non-zero mean value of x of t, we are having something value of the mean value for y of t, that is nothing but 2 into x bar. We have found out the E of y of t. Now let us consider sigma y square. Sigma y square is nothing but again m2 minus m1 square. First we will calculate what is m2. That is a mean square value of y of t. E of y square of t. Substituting this corresponding y of t, this is equal to E of, from the given problem, this is nothing but y of t, this is x of t plus x of t plus tau for this whole square. Then we are going to calculate in the expected value. Apply a plus b whole square. This is equal to E of x square of t plus x square of t plus tau plus 2 into x of t into x of t plus tau. Now apply theorems on expectation, that is E of x plus y is equal to E of x plus A of y. This is equal to E of x square of t plus E of x square of t plus tau plus 2 is a constant, get out of the expected value, that's why 2 into E of x of t into x of t plus tau. Now here you can see that from the properties of the autocorrelation function, these two are the mean square values which are nothing but equal to the ACF at the origin. Therefore, M2 can be written as, this can be written as simply R xx of 0 plus second one is also R xx of 0. Now here you can observe this is nothing but from the definition of the autocorrelation function, it is equal to simply plus 2 into R xy of tau. Generally this is equal to R xx of t comma t plus tau. Now in the case of the WSS process, this is nothing but equal to R xx of tau. Further simplifying, this is equal to 2 into R xx of 0 plus 2 into R xx of tau. Taking 2s common here, 2 into R xx of 0 plus R xx of tau. That means M2 is given as by using this expression. By substituting that here in the case of variance, we will calculate sigma y square is equal to, sigma y square is nothing but equal to M2 minus M1 square. This is equal to 2 into R xx of 0 plus R xx of tau minus what is M1? That is a mean R e of y of t. So this is nothing but M1 only. Now substituting that there, we will obtain as 2 into x bar whole square. Further simplifying, sigma y square is equal to 2 into R xx of 0 plus R xx of tau minus 2 square is nothing but 4, this is x bar square. Therefore, this is the variance of the random process y of t, that is sigma y square. Like that, we have calculated the both A, B, C for the given random process y of t in terms of x of t. And the next problem is, for a given random process x of t, autocorrelation function is R xx of tau is equal to 36 plus 16 by 1 plus 8 tau square. They have given the autocorrelation function. Find out. The first question is mean. Second one is mean square value. And third one is variance of the random process. So this problem is based on properties of autocorrelation function. Because they are going to giving the autocorrelation function, by using those properties, we can calculate these three. First, we will calculate the mean value. Let us write the given equation. R xx of tau is equal to 36 plus 16 by 1 plus 8 tau square. Now we have to find out what's the mean value. In my previous videos, I have explained the properties of autocorrelation function. In that, one of that is limit mod tau tends to infinity, R xx of tau is equal to x bar square, where x bar is nothing but mean of the x of t. Therefore, x bar square is nothing but limit mod tau tends to infinity. Now instead of R xx of tau, substitute the given equation, that is 36 plus 16 by 1 plus 8 tau square. Now apply the limits for this case. This is equal to 36 plus 16 by 1 plus 8 into, now the tau value is nothing but tending towards infinity. Infinity whole square is nothing but equal to infinity only. Further simplifying, this is equal to 36 plus, here you can observe that 8 into infinity is infinity, infinity plus 1 is nothing but is also equal to infinity, that is 16 by infinity. That is equal to 36 plus something by infinity is nothing but equal to 0. That's why this can be written as 0. Therefore, this is equal to simply 36. That means x bar square is nothing but 36. We want the mean value, that means x bar, which is also equal to the e of x of t, is nothing but square root of 36, that is equal to 6. That means the mean value of the given random process x of t is nothing but 6. This is the way to calculate the mean value by using the properties of autocorrelation function. Coming to the next one, mean square value. To calculate the mean square value, use one more property of autocorrelation function, that is e of x square of t is equal to rxx of 0. This property gives, of course, the power of a random process, or the mean square value is equal to simply the autocorrelation function at the origin. Simply put, tau is equal to 0. Now substituting this here in this case, this is equal to 36 plus 16 by 1 plus 8 into, now instead of tau as written as simply 0, that means 0 square. That is equal to 36 plus 16 by 0 square is 0, 0 into 8 is 0, 0 plus 1 is nothing but equal to 1. This is equal to 36 plus 16. If we are going to adding these two, here we are going to getting as 52. That means the mean square value is given as e of x square of t is nothing but equal to 52. This is nothing but the mean square value. Thus, we have find mean value as well as mean square value. Next, coming to the variance of the process. The variance of the random process is nothing but given as sigma y square is nothing but m2 minus m1 square. m2 is nothing but the mean square value, m1 is the mean value. Therefore, this is nothing but equal to, earlier we have calculated the mean square value, that is nothing but this is m2. This is m2. Now, substituting that here, we are going to obtaining as this is 52 minus, earlier we have find the mean value is nothing but 6. Now here it is m1 is nothing but 6. This is 6 whole square. Simplifying, this is 52 minus 6 square is nothing but 36. Then 52 minus 36 is nothing but the 16. Therefore, sigma y square, that is the variance of the process, is nothing but equal to 16. Thus, by using the properties of the autocorrelation function, we have find out the mean square as well as the variance. Thus, in this video, I have explained the problem solving related to the random process temporal characteristics, like finding mean value, mean square value, variance, etc. Thank you.